Hello everyone! Thank you for attending our presentation on hemp fiber. This information will demonstrate how hemp plants are grown for fiber, harvested, and then processed into the raw materials used for various industries. We'll begin by reviewing some basic information about hemp fiber. Here we see a beautiful video of a fresh hemp stalk showing that it is made up of two types of fiber. The whole stalks of the hemp plants are also known as hemp straw, and it is made up of two components. The outer layer of the hemp stalks are referred to as the bast fiber. Bast fiber is just another way of saying bark fiber. These are the long fibers of the hemp plant. The woody inner portion of the hemp stalk is made up of shorter fibers, which are referred to as hurd. The hurd is also known as hemp core fiber or sheaves. What are the sources of hemp fiber? The first source would be from a hemp fiber crop. That is hemp grown specifically for the fiber. The crop is usually planted in early to mid-spring. The seeding rate is This crop is usually planted in early to mid-spring. The seeding rate is 75 to 120 pounds per acre. The stalks grow dense, tall, and thin. The next source of hemp fiber is from a hemp grain crop. This is hemp which is specifically grown for the seeds, which can also be referred to as grain. It is planted in late spring to early summer with a seeding rate of 25 to 35 pounds per acre, making it less dense than a fiber crop. The height of these plants is usually 4 to 6 feet. Last is a hemp flower crop. Here the hemp is grown specifically for the flower. The seeding rate is either 1 seed per plant or 10 to 12 pounds of seed per acre. This crop is harvested just after flowering when cannabinoid levels are at their highest level. Notice that I put a question mark after hemp flower crop. Is hemp grown for flower actually feasible as a fiber crop? Let's find out. Approximately 7,000 acres of floral hemp was grown outdoors in the United States in 2022. That includes all marijuana and CBD crops. The yield of fiber is only going to be at most 0.2 tons per acre. In total, the yield of fiber from all the marijuana and CBD crops in the United States is only about 1,421 tons. This is much too small to fulfill the needs of the industry. Therefore, hemp flower crops as a source of hemp fiber is not feasible. Here we see an entire flowchart for hemp fiber growing, harvesting, and processing. Each of the orange squares represent a process, while the blue circles represent the products created by that process. We will review each step in detail. The first process on our chart is harvesting. Let's look at this step in more detail in the next chapter. Here we see a beautiful hemp fiber crop being harvested. That leads us to our next question. When is hemp harvested? This depends on how the crop is grown. Again, we are looking at hemp grown for fiber. A hemp fiber crop is harvested in late summer, just before flowering, while the stalks are still green. Harvesting prior to flowering results in lower levels of lignin in fiber.
All right, not cutting it over.
That leads to the next question. What is lignin and why do we want lower levels? Lignin is a type of plant glue which holds the fibers together and gives the plants their strength and rigidity. As the plants enter the flowering stage, more lignin is produced, increasing the rigidity of the stalks. More lignin results in less cellulose fiber as a percentage of the bark. Therefore, when the lignin is removed during the degumming process, the customer ends up with less fiber. What about hemp grown for grain? Grain crops are harvested in late fall around October and November after seeds mature. By this time, the stalks are brown and dry. These stalks have much higher levels of lignin and are therefore not as valuable. What types of machinery are used to harvest hemp? The sickle bar offers a convenient method to cut hemp stalks at their base. As you can see by the video, after cutting, the stalks are left in the field for retting. That leads to our next question. What is retting and why is it needed? Retting is equivalent to rotting. It is a process employing the action of bacteria and moisture on plants to dissolve or rot away much of the cellular tissues and pectins surrounding bast fiber bundles. This facilitates the separation of the bast fibers from the stalks. Retting is required to partially decompose the hemp stalks to make it easier to separate the bast fiber from the hurd during decortication. There are two different methods of retting. The first method is field retting. The stalks, once cut, are spread in the field in thin, uniform layers. The water comes from the moisture in the air. The time it takes for retting depends upon the locality, humidity, temperature, depth of stalks, and kind of bacteria present. However, there are potential risks during this process. Over-retting can result in degraded fiber, while under-retting makes it more difficult to decorticate. The stalks may need to be turned over to provide uniformity in retting, involving additional time and labor. If the climate is too warm and dry, the stalks will dry out and not decompose properly. And if there is a prolonged rain, the stalks could decompose, completely destroying the crop. The second method is water retting. Here the hemp stalks are placed underwater to facilitate the decomposition. This could be a natural environment such as a lake or stream, or a tank of water where the temperature may be controlled. Water retting is faster and more precise, but requires more time and effort to move the stalks from the field to the source of water. On a larger scale, this becomes increasingly difficult. After the fiber has been retted, a rake machine is used to straighten and narrow the rows of dried stalk. This is necessary for the stalks to line up properly for baling. Baling equipment is used to pick up the rows of hemp stalks and bale them. Baling is needed to conveniently move or store the hemp stalks. The hemp can be baled into either square bales or round bales. But which method is better? Square bales offer more efficient space for transport. However, round bales hold more weight and help prevent the fibers from tangling. This decision may also be determined by the type of equipment used at a decortication facility, which could favor one or the other. Will hemp straw bales become a commodity? This is possible since they represent a fairly uniform raw material produced from growing hemp. This leads us back to our flow chart and the next step in our process. Post-harvest processing. Here we see hemp stalks being processed in a cotton gin, which has been modified to work with hemp. What type of processing is required for hemp stalks after they've been harvested? The step after harvesting and baling is decortication. Decortication is the process where the hemp bark fiber is separated from the core fiber. Usually this involves the physical crushing of the dried hemp stalks using a hammer mill, decortication machinery, or a modified cotton gin. The broken hemp stalks are fed into the scutching machine, where they pass between rollers or through blades, applying pressure and friction to the stalks, causing the herd to break away from the fibers. This facility may specifically require square or round bales depending on their equipment. Different types of decortication machinery can result in different fiber lengths. After decortication, we end up getting the first two raw materials. Dirty bast fiber and dirty herd fiber. These two products have little value because the bast fiber is contaminated with herd fibers and the herd fibers are contaminated with bast fiber. However, they may be used for some purposes where quality or cleanliness are not important. This leads us to the next process. Cleaning. Further separation and cleaning of the bast and herd fibers are achieved with shaking tables, screens, and air jets. The quality and value of the fiber both depend on its purity. Both bast fiber and herd fiber have a greater value if they are fully separated and clean from dirt and dust. Let's try it now and see what happens. A little shaking did not seem to work. Let's try a little bit harder. Now we have bast fiber which has been completely cleaned. Much better. The same process can be applied to the hemp herds. When cleaned properly, the herds are free from any contaminants and are more valuable. Back to our flowchart. After cleaning, we get two raw materials: clean bast fiber and clean hurd fiber. Let's take a closer review of these two raw materials. Are these two fibers going to be commodities? The answer is no. While the clean bast fiber and hurd fiber have more value, they are not uniform in length. Further processing is needed to achieve uniform fibers suitable for most industries. Back to our flowchart. This brings us to the next process: reduction. The cutting or reduction of fibers is used to achieve desired fiber lengths. Fiber lengths can be reduced to uniform long lengths for insulation, medium lengths for composites, and very short lengths for applications like paper and plastics. Reduction can also be applied to hemp hurds to achieve finer particle sizes. Reduced hurd sizes are used in applications like engineered wood products, such as particle board, and micronized hurd is used in applications such as plastics. Clean bast fibers of specified lengths and clean hurd fibers of specified lengths are the main raw materials of the hemp stalks. These are generally going to be the materials produced and sold by a typical hemp decortication facility. The various processes highlighted in this flowchart are typically performed by a modern decortication facility, and the products shown are what they can offer for sale into the marketplace. Some smaller decortication plants cannot perform all these steps and may not have the ability to clean or reduce the bast or hurd fibers. The size of the facility will determine its capacity. The capacity is defined in tons of raw material produced per hour. Now let's take a closer look at the clean bast fiber, for this is the material that can be processed further by removing the lignin. This is the process called delignification, and it leads us to our next question. Why do we need to remove the lignin from the bast fiber? Here is the hemp bast fiber, which has been peeled away from the stalk. If we look closer, we can see that it is not an individual fiber, but rather more like a ribbon. This ribbon is composed of individual fiber bundles. This separates the fibers from one another, creating thinner fibers. Thinner fibers are needed to create finer yarns when they are spun together. Let's see what this process looks like. Here we can see how this separation process makes the hemp fibers finer, whiter, and fluffier. They are now much more similar to cotton fibers. The next process is combing the fibers. The process of combing is similar to how it sounds. The fibers are drawn through a comb which aligns the fibers in one direction. This also separates the long bast fibers, referred to as line fiber, from the shorter bast fibers known as toe fiber. The long hemp fibers are now ready to go to the yarn mill for spinning. The long hemp bast fibers are spun on equipment designed for spinning flax fibers into linen. These line fibers are typically 4 to 6 inches in length. These longer fibers are used to create 100% hemp yarns. But what about the shorter hemp fibers? The shorter hemp fibers need to be carded. However, they are usually blended with cotton. The short hemp fibers, which are similar in length to cotton, are blended with cotton fibers in varying percentages. Creating hemp cotton blended fiber. These blended fibers then go through the process of carding. Carding is similar to brushing the fibers. It's a mechanical process that disentangles, cleans, and intermixes fibers to produce a continuous web or sliver suitable for subsequent processing. After the blended fibers have been carded, they are ready for spinning. The spinning machines are the same type used to spin cotton fibers into cotton yarns. The lengths of these fibers are between 3/4 inches to 1.5 inches. These highlighted processes are typically performed by a modern yarn spinning facility using the flax spinning system or the cotton spinning system. It should be noted the significance of the short degummed fiber. Will short degummed hemp fiber become a commodity? The answer is yes. This product is the closest fiber to a standard bale of cotton fiber. This is the form of hemp fiber which can be used by the majority of modern spinning facilities. Now let's go to our next chapter. The economics of hemp fiber are almost never discussed. But they are very real and important to understanding the viability of the industry. What are farmers earning by growing industrial hemp? This is an important question. Let's first look again at a hemp grain crop. The farmer is growing hemp for the grain, and the hemp stalks are the secondary product. At this time, the average yield for grain is 800 pounds per acre. Hemp grain is currently selling for 55 cents to 65 cents per pound. This results in a gross income of $440 to $520 per acre. The yield of hemp straw will be about 2,000 pounds. At 10 cents per pound, the straw will yield an additional $200 per acre. Together, the farmer will gross approximately $640 to $720 per acre. Now let's look at a hemp fiber crop. Hemp is grown specifically for the fiber. The average yield is 8,000 pounds per acre of the whole dry hemp stalks, while the selling price for hemp straw is 10 cents per pound. The farmer will gross $800 per acre for growing hemp for fiber. What is the market currently paying for industrial hemp fiber? This table shows the potential gross income to a decortication facility per acre of fiber processed, and it assumes that there is no loss of material during the decortication and cleaning processes. The yield of bast fiber is 1,600 pounds per acre. The current market price is $1.30 per pound for clean fiber. This will gross $2,080 per acre for bast fiber. The yield of the herd is 6,400 pounds per acre. The lowest selling price in the United States is currently 45 cents per pound. This will gross $2,880 per acre. Together, the potential gross income to a decortication facility is $4,960 per acre. So the farmer's gross income for growing hemp is $640 to $800 per acre. While the market will be paying $1.30 per pound for clean bast fiber and 45 cents per pound for herd. This is a big problem. The money farmers can earn from growing hemp is too low. Most of them will not want to grow hemp when other crops are more profitable. On the other hand, hemp bast fiber entering the market is too expensive to compete with cotton or synthetic fibers, and the cost of the herds make them too expensive to competitively be used as a building material or animal bedding. Does this mean our dreams of a hemp fiber industry are going up in smoke? Is there a solution to this problem? Why don't we just pay farmers more money? While doubling the amount we pay for hemp straw will certainly be better for the farmer, this will double the price of the raw materials, making it even more difficult for them to enter the market. Can we lower the cost of post-harvest processing? This is a good question. Can a modern decortication facility lower their operation expenses? One way to do this is economy of scale. Can we build a bigger decortication facility, which will result in lowering the production costs? This is actually being done right now with newer and larger decortication plants coming online. Let's see how this will affect the costs. Increasing the capacity of a decortication facility can lower production cost, but larger facilities cost tens of millions of dollars to construct, requiring a huge initial investment in the equipment. However, this does not help the farmer, who will be still grossing between $640 and $800 per acre. But it does lower the cost of processing. In this scenario, we will assume processing costs are lowered by 25%. The bast fiber enters the market at 98 cents per pound, and the herd enters the market at 34 cents per pound. While this is better, the raw material costs are still higher than competing fibers. Is there another way? Let's take a step back. We need to think outside the box. This leads us to the next chapter, green decortication. What is green decortication? Green decortication is the process of both harvesting and decorticating hemp stalks at the same time in the field while the plants are still green. What are the benefits of green decortication? There are many. The first is cost. Since the harvesting and decortication would be done on the farm, there's no need to build a conventional decortication facility, which can run in the millions of dollars. Transportation costs would be lowered since there would be no need to ship the stalks to a decortication facility. The second benefit is time. The elimination of retting decreases the amount of time the hemp is in the field. This type of harvester has the potential to cut and decorticate 4 acres per hour, which is equivalent of processing 16 tons of stalk per hour. The next benefit is quality. The elimination of retting prevents the decomposition and deterioration of the cellulose fibers. The resulting fibers are long enough and of good enough quality for textiles and other uses. The next benefit is uniformity. Eliminating retting prevents any uneven decomposition. All the hemp is decorticated at the same time, providing uniformity in the product. Green decorticated fiber will set the standard for hemp bast fiber as a commodity. What are the economics of green decorticated fiber? When growing hemp for fiber and using the green decorticated method, it is the farmer who will be selling the separated bast and hurd fibers. The yield of bast fiber is 1,600 pounds per acre. The bast fiber can be sold for 70 cents per pound, yielding $1,120 per acre. The yield of the hurd fiber is 6,400 pounds per acre. If the farmer sells the hurd at 20 cents per pound, that would generate an additional $1,280 per acre. Together, the gross profit for growing a hemp fiber crop would be $2,400 per acre. On the market side, we see the same numbers since the farmers will be selling their crop directly to the marketplace. The clean, long bast fiber will enter the market at 70 cents per pound, while the hurd will enter the market at 20 cents per pound. Taking a step back, we see the farmer's gross income will go from $800 per acre to $2,400 per acre. And the market price for the bast fiber drops from $1.30 per pound to 70 cents per pound, while the hurd price drops from 45 cents per pound to 20 cents per pound. This is much more competitive and allows the hemp fibers to compete directly with other natural and synthetic fibers. It's a win-win for everyone involved. Of course, we must ask the question, is this really possible? The answer is yes. It is being developed right now. Our dreams can be realized. Taking all of this into Taking all of this into consideration, what is the future potential of hemp as a fiber crop? To look into the future, we need to review the past history of other common cash crops. Let's first take a look at the history of corn. Corn yields were mostly static until the 1940s, which saw the advent of modern technology applied to farm production. As you can see, corn yields per acre increased every decade since then, from 24.2 bushels per acre in 1940 to 156.5 bushels per acre in 2010. Now let's take a look at flaxseed production. We see a similar trend with yields beginning to increase around the 1940s, from 6.4 bushels per acre in 1930 to 20.2 bushels per acre in 2010, an increased yield of 246%. Finally, let's take a look at cotton production. We see the similar trend of yields beginning to increase in the 1930s from 162.6 pounds of cotton per acre to 824.8 pounds of cotton per acre in 2010, an increase in yield of 577%. When we look at many of the crops grown today, we see similar trends of increasing yields. The minimum increase in yield was for canola at 152%. The average yield increase of all crops was 538%. And the maximum increase in yield was 1,162% for potatoes. What happens if we apply these trends to hemp? Remember, hemp has been federally outlawed since the late 1930s, just before the advent of modern agriculture. The traditional and still current yield of hemp fiber is 4 tons per acre. If we apply the minimum increase in yield of 152%, we get 6 tons per acre. If we apply the average increase in yield, we get 21 tons per acre. And if we apply the maximum increase in yield, we get a whopping 46 tons per acre. How will this progress affect the economics of hemp? As an example, let's take the minimum increase in yield and apply it to industrial hemp. Let's assume the production of hemp fiber increases from 4 tons per acre to 6 tons per acre. The yield of bast fiber increases to 2,400 pounds, and the yield of hurd increases to 9,600 pounds. At the same prices, the farmer's gross profit increases to $3,800 per acre. Taking a step back, we see modern farming techniques can increase the farmer's gross profit from $2,400 per acre to $3,800 per acre. And the market is still paying 70 cents per pound for green bast fiber and 20 cents per pound for hurd fiber. $3,800 gross income per acre for the farmer is substantial and higher than most common crops. At this income, lots of farmers are going to want to get in on the action. And more farmers growing industrial hemp is going to spur competition. Let's assume the competition drives down the price of hemp fiber by 25%. The yield will be the same at 6 tons per acre, but the selling price of the green bass fiber drops to 52 cents per pound, and the selling price of hurd drops to 15 cents per pound. Stepping back, the farmer's gross income adjusts to $2,700 per acre. Still a good amount. And yet the market is now only paying 52 cents per pound for green bass fiber and 15 cents per pound for hurd. This is significant because the fibers are now priced lower than the current natural fibers on the market. Imagine using hempcrete in your building project where the hurds are only 15 cents per pound. This is going to drive up demand for hemp fiber even further, resulting in even more farmers growing hemp. Is this really possible? Can we achieve higher yields? The answer is yes. We grew hemp for the first time in California in 2021 and yielded 6 tons per acre. We achieved this because we were applying modern cultivation methods to hemp, such as drip irrigation and fertilizers.